Exercise 13 from Chapter 9. It says here in an article in Newsweek, the natural ratio of girls to boys is 100 to 105, not quite 50-50. In fact, in China, the birth ratio is 100 to 114, which is even less than 50-50. You got 46.7% are girls. So suppose you don't believe the reported figures, and you conduct a study yourself. In the study, you count the number of girls and boys born out of 150 randomly chosen births. 60 girls and 90 boys were born. So based on your study, you believe the percent of girls born in China is 46.7. So this is clearly a proportion problem, percentage or proportion, and you're looking to check if the percentage born in China is 46.7. So, if that's your plan of attack, this is an equal sign. This is your null hypothesis, which means your alternative hypothesis is the not equal to symbol. The proportion is not equal to 46.7. And now that you have that, you know that you're conducting a study on the proportion. So your random variable that you're looking at is p prime. And in p prime, you have your mean and your standard deviation from a normal distribution, whatever these are. So p and the square root of pq over n. So in any case, this is you're doing a proportion problem. And in proportion problems, usually there's things that you're looking for. You're looking for p prime, you're looking for x, and you're looking for n. And your x and n are based on a sample. And the sample that you got, we want to know, by the way, that your p is, as a success here, is counting the number of girls born. Okay, we're going to go directly to our calculators. And let's go to stat and test. And we are doing a proportion, so we're going to skip the first two over here, and the first four actually, and go to option number 5, the one prop z-test. So one prop z-test, the first thing that they ask for is what is your proposed value. So remember that these are percentages that you need to change back into decimals. So 0.467 is what we're looking for. We have an x and an n that they're looking for. So we have, it turns out that we got 60 girls out of 150. So the 60 girls are going to be your x value, and 150 would be out of your total n. The next is under alternative hypothesis, your proportion is some symbol with a 46.7%, and so we'll use the not equal to symbol here. Already selected. Let's go to calculate, and in our calculations we get a z-value, our test statistic. We'll have a z-value of so this is a normal distribution, that's why we're doing the z-value, negative 1.645, let's call it. And our p-value is going to equal to 0.1000. So let's just call it 0.10. With a 10%, it looks like it's pretty large, in terms of hypothesis test measures. And again, if there's no significance level, we kind of assume the significance level is 0.05. In this case, it's the p-value is greater than 0.05, so we fail to reject the null hypothesis. So we're going to say that we were attempting to reject the null hypothesis. We're attempting to disprove that. But based on our data, we were not able to disprove that. So it looks like we weren't far enough away from 60 or from 46.7%. I think if we went a little bit lower, if there was a lot less girls that were born, then we could probably have said that. So, based on your study, do you believe that the percent of girls born in China is 67%? So you can say that we're fairly close to 67%. I mean, you can actually do the calculation and try to figure out what 60 divided by 150 is. And that's 0.4, so that's fairly close. So we're not able to disprove the 46.7% claim. And yeah, like I said, 40% is fairly close. Another thing you could do is you can create a confidence interval by going to test. And remember the confidence interval from the last chapter, when we're doing a confidence interval for a proportion, we use the one prop z int. One thing you'll notice is that if you've done this already as a z-test and you do a corresponding confidence interval, your data is going to be there. And let's check a 95% confidence level. So 95% confidence level. A confidence interval gave us 0.3216 and 0.4784. You could see that 0.46 is somewhere in the confidence interval. Now, if you're trying to disprove this, or you're believing that it's not 46%, then your confidence interval should not contain the 46%. And it looks like at the 95% confidence interval or confidence level, 46.7% is still within your confidence interval. So you were not able to disprove it that way either. Okay, so I think this would be the good final statement for this problem. We were not able to disprove the 46.7% claim. So it looks like we're going to have to believe it based on our data. Okay, I hope this helps with the homework set.